Today I'm just going to show you how to do some practice problems using electronegativity difference to identify the bond type. So in this, we're not going to worry about the elements involved because that is a faster way of doing it. I want you to actually do it based off the E.N.D. So I'm going to do one problem with you. We'll start with the very first one. So this part is just a review. It's actually the notes. It says, you know, if the E.N.D is greater than 2 or greater, should be an underline there, equal to 2 or more, it's ionic, and if it's greater than 1 but less than 1.0, greater than 0 and less than 1.9, it's polar covalent, and if it's exactly 0, then it's non-polar covalent, which means perfectly equal sharing. All right, so for the first one, NaCl, you'd have to go to table S, which is on your reference table, and then we find Na, which is element 11, and its E.N.D is 0.9, so I write 0.9 here. And then you go to chlorine, and it's 3.2, and you write chlorines in. And then you find your electronegativity difference. You just subtract, make it a positive number, you get 2.3. Once you're done with that, you figure out which category it fits in. Well, this one is ionic. And then you're just going to do that for the entire list, figure out what bond types they are, and then when you're done, you're going to rank them based off polarity or ionic character. So whichever one has the largest E.N.D, that would be the highest polar or the most ionic, and therefore it is going to be number 1, and then you're going to rank them all the way down to the ones that are 0, and they are going to be nonpolar. Now, if any of these bonds happen to have the same E.N.D, which does happen more often than you'd think, you would rank them the same rank. So if I had 2 bonds that were tied where their E.N.D was 1.0, I would say, all right, they're the same rank, and then I would just keep moving on from there. And that's all you're going to do with this sheet. I don't want you using, you can actually, if you want, double check it with element type. You can go in and say, all right, is that a metal? Is this a non-metal? Okay, metal, non-metal means it's ionic. And so you can go in and double check to make sure it's right. It works 99% of the time. The only time you have issues is when you get something that's in this like kind of gray area where you get like a 1.9 or an exactly 2.0 E.N.D. Sometimes that might not work all the time, which is why knowing how to do the E.N.D is important, because if you get an element or a bond that happens to have a 1.9, sometimes depending on if you do it based off the elements, it might come out ionic. And the same goes with 2.0. If you do it based off the elements, it could come out polar covalent, but if you do it based off E.N.D, it won't. So just be aware of that.